and thanks for taking the time to listen and hear about some of the research out of UMBC. My name is Janine, and I'm a fourth-year PhD student working with Dr. Kevin Omland on the Bahama Oriole project. And as the name suggests, I know this is the Maryland Ornithological Society, but as the name suggests, the Bahama Oriole is found in the Bahamas. This is a non-migratory species, so it's a year-round resident of the Bahamas, but really what's special about this bird is that within the Bahamas, it's only found on one island, the island of Andros. Well, actually, this is a collection of smaller islands, but collectively referred to as the island of Andros. And because of its restricted range, along with previously low population estimates, the species is listed as critically endangered by the International Union for the Conservation of Nature. So that's the IUCN, which you might be familiar with. And given that habitat loss is one of the most prominent factors driving local extinctions, it's crucial that we understand, how much available habitat is there for the Bahama Oriole throughout this restricted range. Furthermore, in order to inform conservation planning, it's useful to understand, what factors are driving habitat loss. What do we need to be paying attention to on Andros? So the habitat we're most interested in for the Bahama Oriole conservation is the Caribbean pine. It's actually a Caribbean pine rockland forest. Is what it's called, and I'll explain it a little bit more later. But that's what I'm going to talk to you about here, monitoring the disturbance of this Caribbean pine forest of Andros, home of the critically endangered Bahama Oriole. So to follow up that introduction with another introduction, forests in general provide critical habitat for countless species across the globe, and as such, forest loss is really one of the greatest threats to global biodiversity. And the pine forests on Andros, like I mentioned earlier, actually represent a unique subtype of open canopy forest with a coral rock substrate, and so that's where it gets that name, the pine rockland habitat. And this is a fire-adapted ecosystem, meaning it really relies on fire to prevent understory broadleaf vegetation from outcompeting and taking over. And you can only find this type of pine forest in very small parts of southern Florida, Cuba, and the Bahamas. So furthermore, the pine species that dominates these open forests on Andros is a subspecies of Caribbean pine that's only found on 4 islands in the Bahamas. So this globally unique habitat, it's an endemic subspecies that houses a globally unique bird species. And given all of this, with this special habitat and subsequently the Bahama Oriole, because the bird depends on this habitat, are threatened or may be threatened with factors associated with human activity and climate change. And now I'm going to talk a little bit about those. So the potential impacts of climate change on the Caribbean pine forests are multifaceted. First off, we're seeing an increase in the frequency and intensity of hurricanes in the Caribbean. These storm events often lead to saltwater intrusion of the freshwater table, which is what the forest largely depends on as a water resource. Furthermore, large amounts of debris that end up scattered throughout the forest floor, ultimately elevating fuel level loads that can drive particularly intense fires that may exceed what these fire-adapted forests are used to. Here, just draw your attention to figure 1 below. It shows a satellite view of Hurricane Dorian, if you remember, from 2019, as it hovered over the island of Abaco. And then here to the right, it illustrates the devastation that such a strong storm event can incur on the forests. But back up here, so fires are also expected to increase in frequency and intensity as air temperatures rise and precipitation falls. And also keep in mind that lower precipitation ultimately means fresh groundwater isn't being restored as efficiently, particularly following a storm event. So really all of these things are intertwined, unfortunately. And then of course there's good old-fashioned human disturbance where forests are cleared for residential development and agriculture. All right, so jumping down here. As I previously mentioned, research-based conservation of the Bahama Oriole, which is my focal species, this requires an accurate understanding of the drivers and rates of habitat loss. There are maps out there publicly available documenting forest loss at the global scale, particularly Hanson's Global Forest Change map, but this varies in accuracy, depending on the type of habitat, things like that. And it's been shown by some researchers to either overpredict or underpredict disturbance. So really, it's unclear how much forest loss is actually occurring on Andros. And here, the figure below, these are just meant to familiarize you with the geographic location of Andros on the left. So it's just a couple hundred kilometers southeast of Florida. Collectively, Andros is about the size of Delaware. And then to the right is just a typical scene from within the pine forests of Andros with an understory of broadleaf vegetation and a very open canopy. Okay. So given everything I just discussed, my objectives were to 1, map the habitats of Andros, 2, measure landscape level characteristics of Caribbean pine. So these included extent, patch size, and isolation. And 2, assess the accuracy of the global forest change map for Andros and determine the current drivers of forest loss. And this schematic here just provides a summary of the overall approach I took. So in order to accomplish this, I retrieved satellite imagery of Andros from the United States Geological Survey, as well as on-the-ground field survey data. And I used the satellite imagery and the field data to train a classification model. And we use what we call a random forest model to map the habitats of Andros. And we did this at a 30-meter spatial resolution, so it's fairly high. And then I followed this up, of course, with an accuracy assessment, right? We need to make sure our map is mostly accurate if we're going to use it for any downstream analysis, as well as those landscape metrics I mentioned and the global forest loss comparison. All right, so jumping down to the results, at the end of this, we had a map delineating 9 terrestrial habitats on Andros. And you can see that in the figure below to the left. And the pine forest is represented by the Kelly green. And the table to the right is just the accuracy assessment. So the only thing I want to focus on here is that we have pretty high accuracy for predicting the Caribbean pine habitat. All right, importantly, we found that of all the classes, Caribbean pine was the most extensive habitat type on Andros at roughly 1,400 kilometers squared of Caribbean pine. We did, however, find that the distribution of pine was somewhat patchy. So most of the pine area was present in small patches less than 0.2 kilometers squared. So this number is notable because we have preliminary data that's suggesting orioles are using at least 0.2 kilometers squared territory sizes in the pine forest. So we suspect that they at minimum need a roughly 0.2 kilometers squared. So having patches smaller than that might not be the best news, but we did find that most of the patches, about 75% of the patches, were quite close to another patch of pine, so within 100 meters. And so this may compensate for that by allowing birds to move more easily among multiple patches, and thereby having access to more resources among those patches. But there are, however, quite a few very large patches that could potentially sustain a sizable number of orioles. Okay. Let's see, let's go up here now. When we compared the global forest loss map with our local map on Andros, we found that the global map did over-predict forest loss on Andros. And we also determined that human disturbance, although it's minimal, is currently driving forest loss on Andros, or it's the main driver of forest loss that does occur on Andros, as opposed to those factors I mentioned earlier, including climate change, hurricane damage, and fire. All right, so the figure here distinguishes between what we're calling true forest loss, which is in the dark red, and it's hard to see because there's not much of it. Again, good news overall for the oriole and other species using this pine forest. But also what we call false deforestation, and that's represented by this lighter pink color, while the gray represents what our local map classified as either agriculture or developed. So that's already area that has been cleared previously. And the takeaway here really is just a large amount of false deforestation on Andros, and this is just evidence that the global forest loss map over-predicted loss on Andros. This is also evident in the table directly below, so jump down to here. So here we took a subset of 100 points from the forest loss map, and we visually assessed them to see what the status of those forests were after 2 years of following the loss event. So did they recover or did they not recover? And here you can see that roughly 85% of the forest loss predicted by the global forest map in 2017 and 2018 were actually intact forests. And So of the small percentage of true forest loss that did occur, 100% of that in this analysis was driven by anthropogenic activity. And now let's talk a little bit about the fire. So this table here shows that the pine forests on Andros are very resilient to understory fires, importantly under the current fire regime, so the current frequency and intensity of fires. And in this analysis, where we looked at a subset of 100 random areas that had experienced a fire event, we found only 2% of the time did fire result in true forest loss. So looking at the current status of the forest in that area where a fire event occurred, only 2% of the time did we find that patch of pine to still be damaged, and we consider that forest loss. Again, you can see here that anthropogenic activity drove most of the forest loss in this subset as well. And the image to the right is just a fun image to sort of illustrate what a typical understory fire looks like on Andros. It looks scary, but it's just a natural occurrence here. It's required to sustain these Caribbean pine-dominated habitats, but importantly under the current fire regime, which again, rising temperatures and decreasing precipitation could change in the future. All right, so I better wrap things up. For really what this means for the future, this map provides baseline data with which we can track changes in habitat distributions over time, and we can continue to monitor disturbance. Furthermore, this map allows us to monitor the impacts of climate change as they continue to affect the region. So we can see how the extent and patchiness of pine changes over time, and then do further analysis to, assess whether or not this is fire-driven or hurricane-driven, et cetera, et cetera. Because yes, fire is a normal occurrence and rarely results in forest loss, but what happens when hotter and drier temperatures and climate, comes with climate change, and increased fuel loads result in more frequent and intense fires. So it's definitely something we want to keep an eye on with regards to monitoring the Bahama Oriole habitat. And we also showed that global forest change map is largely inaccurate for this type of open pine forest habitat, and we suggest that researchers take this into consideration when implementing the global map into their work, if they're doing work in an open sort of savanna pine habitat. All right, well, that's all I have, and I'd like to thank my funding sources, of course, the National Science Foundation, Birds Caribbean, the Florida Ornithological Society, and the American Bird Conservancy. I'd also like to thank our colleagues at the Bahamas National Trust, and a special thanks to the Rudd family for their generous housing donation on Andros. All right, I hope you guys enjoyed that. Thank you very much.